Welcome to LinMot Tutorials. In this tutorial, we will size the linear portion of a cap torque checking application. First, go to the Info tab in Global Settings and enter our notes. Here is the tooling mass. Let's select the motor we chose in Part 1. The link to Part 1 will be in the description. Go to Global Settings and click on the motor box. The category is Linear Rotary Motor Linear Part. The group is PR02. The family is the PR02 52x60 motor. Let's start with no MagSpring. We will use K05 4-meter cables. Next, go to the Load tab to enter our tooling mass of 200 grams. We will also select the vertical down orientation. The motion profile consists of a rotary axis and a linear axis. We will focus on the linear axis. The linear axis will dwell for 100 milliseconds. Then it will move down 100 millimeters in 250 milliseconds. It will hold down the bottle for 500 milliseconds as it screws and torques the cap. It will dwell another 100 milliseconds, and then finally it will move back up in 250 milliseconds. Now let's create our motion profile. Segment 1 will be a 100 millisecond standstill. Segment 2 will be a sine move of 100 millimeters in 250 milliseconds. Segment 3 will be a 500 millisecond standstill. In the local load settings, we will apply 22 newtons to the external force to hold the bottle down. Segment 4 will be another 100 millisecond standstill. In segment 5, the motor will move 100 millimeters back up to its original position. Now let's size the MagSpring. Let's go to the Motor tab in Global Settings, click on the motor box, and try a MagSpring with a pull of 30 newtons. Go to the Load tab in Global Settings. We must overcome the system friction of 10 newtons for the motor to move upwards without power. With this MagSpring selected, let's check Segment 1's segment results on the left side of the window, as Segment 1 is a standstill segment. Here, we can see a positive peak force that is above 10 newtons. To complete the entire linear rotary sizing, we need to insert the power dissipation of the other motor into the Load tab in Global Settings. In other words, we need the power dissipation of the linear motor in the rotary sizing's load settings and the rotary motor's power dissipation in the linear sizing's load settings. If we open our rotary sizing, we can see that the power dissipation is 8.25 watts. Let's enter that into the Power Dissipation Second Motor box in the Load tab of the linear sizing. The linear sizing has a power dissipation of 2.55 watts. So let's enter that into the Load tab of the rotary sizing. We can see both sizings have no errors or warnings. This concludes the sizing and this tutorial.